Hello everybody. I thought I would, for this section here, we would do a little video description of it. We've done this a few other times. So this section here, there's a couple more sections of trig left. Okay, and this one here, section 5.4, sum and difference formulas. It's one of them we always kind of debate sometimes whether to even cover, because the actual trig itself, there's not a ton that's going to get used in the future. A lot of the other stuff I can say, yeah, we're going to need to see graphs, we're going to need to solve equations, different things, identities. This one, there's not a lot, but one of the things we're going to do in the next section, 5.5, is something you may see, and to kind of get to that, we have to do this. But what I do think is important is the algebra that's behind all of this. I think we need a review on that for many reasons. There is some algebra here that you need to be reminded of, reviewed, and worked through so that you're a little more successful next year if you move on to calculus. All right, so saying all that, so these are sum and difference formulas. They're used to find exact values of trig functions not on the unit circle. So these formulas used to be very important because it'd be the only way you could find exact values of other things that weren't on the unit circle. You know, nowadays we do have calculators and we can get decimals, which are great approximations. But we even have like the TI-89 will give you exact values for anything as well. So, but that's what these formulas are used for. So we'll just jump into it here and we'll take it piece by piece and look at the different algebra that's going on here. All right, so here's the first set of formulas. I would suggest that you take notes during all of this, if I haven't already said that, which I don't think I have, and have some notes, in particular the formulas. So you might want to pause this right now and write that formula down. There's two of them there, cosine u plus v. U and v are just going to represent angles. You'll see what I mean when I do the examples. I have another set of formula sheets I give out. They have an A and a B. It really doesn't matter what the letter is. Okay. All right. So the first problem is asking for cosine of 15. Well, 15 is definitely not on the unit circle. Okay. So what you want to do is you want to think about two values that are on the unit circle that add or subtract to 15. So you look at your unit circle and you ask yourself what two values add or subtract to 15. Okay. Well, we can see 45 and 30, 60 and 45, 135 and 120. We can even do 315 and 300. It really doesn't matter which two you choose. Okay. You just want to choose any two. All right. So we're going to choose 45 and 30. So they subtract, by the way, not add, of course. So what we're going to do is we're going to write cosine. Oops. Okay, not sure what happened. There we go. Cosine of 45 minus 30. Okay, so that's what we're going to use. So then we're going to use this formula right here. Okay, we're going to use this formula right here. This one, for some reason, my pen is not working right for me. That one. So what is that going to look like? Well, cosine of 45 times cosine of 30 plus, make sure to get that sign correct, sine of 45 and sine of 30. A couple things here that we're going to do to make this easy. You're not going to have to memorize these formulas. You'll be given them at any time. Second thing, we're going to only work in degrees, not in radians on this. I don't need to add that extra difficulty with fractions, so it'll only be degrees. Okay, so then from here, it just goes about unit circle and a little bit of algebra. All right, so cosine of 45 is root 2 over 2. Cosine at 30 is root 3 over 2. Sine of 45, root 2 over 2. And sine at 30 is 1/2. Again, I'm looking at my unit circle, going to 30, cosine is x, sine is y, 45, cosine x, sine is y. All right. Now here's the sum of the algebra. This is the simpler algebra of the two things we're going to look at. We multiply fractions. A root 2 times a root 3 is a square root of 6. And 2 times 2 is 4. When you multiply numerators and the denominators. Multiply across, root 2 times 1 is root 2, 2 times 2 is 4. And then the only other thing we're going to do is root 6 plus root 2 all over 4. We can't add radicals that aren't the same. A root 6 plus a root 2 does not add together, so we have to write them like that. All right, same with subtraction. Now multiplication, we can multiply the two radicals like we did in the first step there, root 2 times root 3, but we can't add them when they're different, and that's my answer. Okay, if you chose different values between like 135 and 120, you're going to end up with the same thing. You might end up with root 2 plus root 6, same thing. Okay, all right, let's look at another problem here. We're going to do the same formulas, cosine again, and we need to find two values that add up to 105 or subtract. It really doesn't matter. I'm going to do this as an addition problem, but we could do it as subtraction as well. Okay, so if I look here, I'm going to do 60 and 45. All right. All right. So using our formulas from the previous page, right? Cosine U, cosine V. So cosine 60, cosine 45, and then minus, and then sine 60 and sine 45. So again, you see that formula there. Make sure it's a minus for this one. Okay. Take a moment, maybe pause the video. Why don't you try to solve this? All right, cosine of 60 is 1/2. Cosine of 45, root 2 over 2. Sine at 60 is root 3 over 2. And sine at 45 is root 2 over 2. Now, you're going to end up with problems that are going to look the same over and over and over again. Notice these are the same kind of values we had up above. So this is root 2 over 4 minus root 6 over 4. The difference is when I bring this together, I'm going to get root 2 minus root 6 all over 4. Okay. One thing you may have, if you chose different numbers, you might have gotten negative root 6 plus root 2 all over 4. Same thing, just rearranged. All right. Okay. So next one, and by the way, we're going to go through. There are sum and difference formulas for cosine, for sine, and tangent. Okay. Sine and cosine work exactly the same way. Formulas are very similar. I had to pause that there for a moment, guys. All right. So again, you're going to get sine and cosine. You're going to get similar answers for sine and cosine. The formulas are a little bit different. Again, you're going to get to use the formula. So I'm going to give you the formula here for sine. Like I said before, you might want to pause it so you can write it down. You have to be very careful, make sure to write them correctly, and make sure when you're using them, you use them correctly. That's the biggest mistake that students make on these, because it's pretty easy mathematically. Now, a couple of the examples that I'm doing here, there's a couple things that I'm trying to show you with these. Like I said, these formulas work the same way, whether it's sine or cosine. So what I'm talking about here with sine would apply to cosine as well. I want to find sine in negative 75. So again, we have to find things that are at a subtract to negative 75 that are on the unit circle. Let me clarify that too. Previous problem was 105. Yeah, I know 100 plus 5 gives me 105, but neither of those things are on the unit circle, so that doesn't do me any good. Negative 75, if I look at my unit circle, this one's a little more of a challenge here at first. Somebody might look at that and go, negative 30 and negative 45. Yeah, you can do that and add them together, but it's a little bit of a challenge to think about this in terms of a negative. I don't think we're all that great at that, so I'd prefer you didn't. The other way to get a negative is when you subtract two numbers, you take a small number minus a big number, right? So if you look at your unit circle, if you can come up with two numbers that subtract to 75, really that's what you look for. Two numbers subtract 75, but when you want negative, you'd put the small one first. So for example, 60 and 135. 135 minus 60 is 75, so if I do it the other way around, it will work. So if I go sine 60 minus 135. Okay, that does give you negative 75. So then you just plug in your formula. Again, we're going to use this one here. So sine 60 cosine of 135 minus then cosine of 60 and sine of 135. Okay, and then it's a matter of just using your unit circle. So sine at 60, well, that's root 3 over 2. Cosine at 135 is a negative root 2 over 2 minus cosine at 60 is 1/2, and sine at 135 is root 2 over 2. Notice we have a very similar numbers as the two previous problems of cosine. You just have to watch the signs. So this will be over 4. Root 3 times root 2 is root 6, but it's a positive times a negative, so it's a negative, minus, and this gives me root 2 over 4, and then I put it together, negative root 6 minus root 2 all over 4. So the answers that we're going to get for these types of problems are all going to have a root 6, a root 2, and a 4 on the bottom. Should make sense because the combinations of the unit circle of root 3 over 2s, root 2 over 2s, 1/2, putting them together, these are the things you're going to get. The things that are going to change are the signs. Okay? And again, if you chose different values, you might have gotten negative root 2 minus root 6 all over 4. It's the exact same answer. All right? All right, so that takes care of all the sines and cosines. They're very similar to those three examples that I gave you, just different problems, different numbers, but you're going to get values of pretty much the same. Tangent now, here's the tangent formulas. Again, you may want to pause and write down the tangent formulas. Now, this is one of the main reasons that we are doing these formulas, because the algebra here for the tangents is something I think we need to remind you of. Okay, so take a minute there and write them down if you haven't already. All right, so we want tangent at 255. Again, we're looking for two values on our unit circle that add or subtract to 255. Probably the one that jumps out to me all the time is, 135 and 120. It gives me 255, so I'm going to add those two. Okay, so tangent 120 plus 135, and it doesn't matter if you write 135 plus 120 because it's addition. All right, so we're going to use the first formula, tan 120 plus tan 135 all over 1 minus tan 120 times tan 135. Okay, so now remember, tangents are written on the outside. Okay, so tan of 120 is negative root 3, and tan of 135 is negative 1. Okay, so this is negative root 3 plus negative 1 all over 1 minus negative root 3 times negative 1. Okay, now a little cleaning that up. Negative root 3 minus 1 all over 1 minus root 3, because a negative root 3 times negative 1 is positive, and we still have that minus. All right, so now here is the algebra that we have to worry about. Okay, the algebra we have to worry about here now is the fact that we have a square root in the bottom, and we have to take care of that. All right, so to take care of that, we don't just multiply by root 3. We multiply by what's called the conjugate. Okay, so the conjugate is this, 1 plus root 3, 1 plus root 3. This is something I believe you should have learned last year in algebra. Not sure under the circumstances of everything last year if that's the case. Now, what you have to do is you have to FOIL all of these things out. I'm going to do it over here. So I have plenty of room. Now, the bottom, you're going to FOIL it out. You're going to go first times first get 1. Outside is root 3. Inside, negative root 3. And then last is a negative root 3 times a positive root 3 gives you a minus 3. Okay? All right. Top, we have to FOIL it out. Negative root 3 times 1 is negative root 3. Outside, a negative root 3 times a positive root 3 gives me a minus 3. Inside, negative 1 times 1 is minus 1. And last, negative 1 times root 3 is a negative root 3. Okay, now, what should happen if you did this conjugate idea correctly, on the bottom, these middle terms should cancel. And you get 1 minus 3 on the bottom. Okay, on the top, combining some like terms, I'm going to do the numbers first. No reason other than I like to. Negative 3 minus 1 is negative 4. Negative root 3 and a negative root 3 give me a minus 2 root 3. We've got 2 more steps. Clean that bottom up. Gives me negative 2. Now, we've got to finish simplifying this. And the way you do this, this negative 2 should divide in to both parts on top. All right. So negative 4 over negative 2 is positive 2. Oops, let me erase that a bit. Positive 2. And then 2 root 3, the 2's will cancel, and we have 2 negatives, so that's a positive root 3. So my answer is positive root 3. Okay? You'll get answers, just like with sine and cosine, we got kind of the similar answers. With tangent, we're going to get answers with a 2 and a root 3. It may be 2 minus root 3, it may be negative 2 minus root 3. Okay? I'm going to go back to the algebra. Back at this step right here. All right? So we have to take whatever's on the bottom and we multiply by the conjugate. Okay? So that's the idea there. You got to multiply that by that conjugate there and then FOIL it out, the top and the bottom. So there's a lot going on here algebraically. It's been a while since you did things like that. Okay? All right. Let's look at one more example. And I'm going to do this one specifically because I want to make sure that we do something in particular here, because there's 2 variations of problems with tangent, basically. So again, we want to subtract 2 things that give you negative 15, and I'm going to choose 30 and 15. Now, if I was doing this problem on my own, I probably would choose 60 and 45. You'll see why. But I'm going to do 30 and 15. So I'm going to do tan 30 minus 45. So again, we're going to use the second formula. So in this case, it does matter. Tan 30 minus tan 45 all over 1 plus tan 30 times tan 45. Oops, sorry. Make sure I use that formula correctly. Yep. Okay. So let's fill in here first. I'll do it off to the side. So tan at 30 is root 3 over 3. Tan at 45 is 1. It's on the bottom. Okay. So what that gives me, cleaning it up a bit, root 3 over 3 minus 1 all over 1 plus root 3 over 3. Okay, so now I'm going to teach you a little algebra trick here, because what we have to do is what we did in the last problem is multiply by the conjugate. But if I do that the way it is right now, it's all fractions and it's ugly. I don't like having all these fractions, so we can get rid of them. And what we can do is if we multiply everything by 3, in reality what we're doing is multiplying the top by 3 and the bottom by 3. But if we multiply everything by 3, what you'll see happens is those will cancel and you get root 3. 3 times 1 is 3. 3 times 1 on the bottom is 3. These will cancel and plus root 3. So what you do need to do when you get a problem that has these root 3 over 3's is make sure to multiply everything by 3 to get rid of the fractions. Now we're going to multiply by the conjugate. And again, it's the conjugate of the bottom. All right. And we FOIL it out. So first times first is 9. Now, when we do this conjugate idea, we shouldn't have to write the middle term out. Outside would be a negative 3 root 3. Inside would be a positive 3 root 3. I'll write it out this time, but in the future, you don't really have to. And then last, root 3 times a negative root 3 is minus 3. Okay. Top, we're going to have to FOIL out. First times first would be 3 root 3. Outside would give me a negative root 9, or just 3. Inside would give me a minus 9. Outside would give me a positive 3 root 3, because it's a negative 3 times a negative root 3. Clean it up a little bit. Numbers first. Negative 12 plus 6 root 3 all over. These cancel, and 9 minus 3 gives me 6. So then the last step would be to separate. Negative 12 over 6 plus 6 root 3 all over 6. Negative 2 plus root 3. Okay, notice you get a very similar answer to what you did before. All right, I hope you've copied these notes down and you have some examples here for yourself for the assignment I'm going to give you on these to try over the next couple days. Okay, on Monday of next week, we'll kind of review this, move on a little bit, practice a few other problems, and go from there. All right, hope you guys have a great day, and we'll see you soon.